nucleophiles and bases. We will try to understand what nucleophiles are and how they are different from bases. So to begin with, let us consider a reaction where CH3 CH2 Br reacts with OH minus to form CH3 CH2 OH plus Br minus. We can represent this reaction something like this: CH3 CH2 Br OH minus. You know, OH has got a negative sign because of the electron pairs on oxygen. There is, so this gives OH. Now there are two pairs of electrons plus Br minus. Now if you look at the carbon here to which Br is attached, there are two hydrogen atoms because it is CH2Br. I'm sorry, two hydrogen atoms. And OH minus donates a pair of electrons to the carbon here. The reason being that this carbon carries a partial positive charge, bromine carries a partial negative charge due to difference in their electronegativities. Thus OH is making a new bond with carbon here. Thus OH minus is a species which donate a pair of electrons, to positively charged carbon to form a new bond. And that species therefore is called nucleophile. Nucleus is positively charged, as we are aware, because of the presence of protons and neutrons. Neutrons are chargeless, protons are positively charged. So this species is nucleus loving. By phile we mean loving or attracted to. So OH minus is attracted to positively charged carbon here, and it donates a pair of electrons to that carbon, forms a new bond. Therefore it is called a nucleophile. Thus nucleophile is a reactant that provides a pair of electrons to form a new bond. Now let's see how a nucleophile is different from a base. Let's consider this reaction. Nitrogen carries a pair of electrons. Water, as you are aware, oxygen carries 2 pairs of electrons. Now this pair of electron of nitrogen shifts to proton of water to produce NH4 plus this carries a positive charge now, and OH minus. O carries a negative charge, and there are 6 pairs of electrons. Now, where is the difference? Here, this OH minus shifts a pair of electrons, or donates a pair of electrons to positively charged carbon. Here, pair of electrons from nitrogen is donated to positively charged proton. This species is a base. This species is a nucleophile. So, when you talk about basicity and nucleophilicity, we are actually talking about these 2 types of events. Basicity, the nucleophile attacks a hydrogen, whereas nucleophilicity, nucleophile, in this case it is OH minus, attacks any atom other than hydrogen. In this case it is carbon. So we can say basicity is a subset of nucleophilicity. So all nucleophiles are Lewis bases. More specifically, it's the Bronsted base. This base is the name we give to a nucleophile. Base is the name we give to a nucleophile when it forms a bond to a proton. Let's talk about some more examples of nucleophiles. H2O, because of the presence of 2 pairs of electrons on oxygen, is able to donate the pair of electrons, therefore it's a nucleophile. OH minus, we have already discussed, is a nucleophile. NH3, because of the presence of a pair of electrons on nitrogen. Cl minus is a nucleophile. CH3 minus, how is CH3 minus formed? From CH4 when one proton is removed, CH3 becomes CH3 minus. All these are nucleophiles. any alcohol because of the presence of pairs of electrons on oxygen. Amines because of the presence of electrons on nitrogen. Carboxylic acids CH3, CH2, COOH because of the presence of pairs of electrons on oxygen is also a nucleophile. There will be 2 pairs of electrons here, 2 pairs of electrons here. So all these are nucleophiles because of the presence of electron pairs, which can be donated to form a new covalent bond. What about methane? Obviously not, because this does not have a pair of electrons to donate. What about NH4 plus? Not a nucleophile. Same reason, no pairs of electrons to donate. Hope you understood the difference between a nucleophile and a base. By nucleophile we mean a species which makes a new covalent bond by donating a pair of electrons with any atom other than hydrogen. When the nucleophile makes a new bond with proton by doing the same thing, donating the pair of electrons, then it makes a base.